So hello everyone and welcome back to my channel. I hope you guys are doing absolutely fine. So in the previous video I had explained about matrix multiplication in order to find the nth term of Fibonacci series, or we could also print n terms of Fibonacci series. So as I've promised, now I'm going to take you over to the Java code that will actually explain or implement of how things are going to go about. So coming over to the matrix multiplication, so I've just created this class called Fibonacci Matrix. So I'm just importing the required set of libraries. This is the IO library and this is the java.utils library for the scanner class. And going ahead, we have public class Fibonacci Matrix. That's the name of the class that we had planned, that I had previously written it. And then we have like public static void main, and inside of that I'm going to define a scanner class as explained in the previous video. So if you haven't seen my previous videos in writing the basic Java code of Fibonacci series or like recursive Fibonacci series, I'll be posting the link in the description below. So I'll just say new scanner class, and that's going to be system.in. So moving further, what we need to consider is, like, already we have the scanner class and we have to take the input of how many terms that is being required by the user, that will be given by the user. So sc.nextInt for taking an integer, and that will be stored in a variable called n, and then that's how it's going to be. So fc.nextInt, so I'll just make a loop for, and as usual, since we are already 3 terms ahead, so if it's like if it has to print 5 terms, then it will be only going like multiplying the matrix twice. So that's how it's going to be, and I'll start it from the 3rd term at 0, 1, 2, and I'll just end it till n and I++, and I'll call a function called multiply. Of course we need to define a matrix here, a 2-dimensional matrix. So all I just do is I'm going to define a 2-dimensional matrix with the following values, like what would that be? 1, 1 and comma, it will be 1, 0. That's what we thought about it. Okay, let this be the A matrix, and we have to define a function that's called multiply, and we'll just send A, and let's define M up there. What we'll have is, okay, so we have 2 options, so I'll send A, and okay, I'll just send the value of A. Since we haven't defined, it's throwing an error, so I'll just say public static. It shouldn't, we can keep it white since we are passing a matrix. It would be reflected. That's because of pass by value or pass by reference. So if it's being requested, I'll also make a video on that. So anything pass by reference indicates that if anything is changed in the matrix, that will be reflected in the matrix, since it actually accesses the memory location of the particular value of the array, and it's like so it's the actual, so any change in the parameters that we are passing and that is being taken by the function, any change in the function would also be reflected if we use arrays in this case. So we'll call it multiply, and that's how it's going to be. So since it's now being multiplied, what we have an int, say A. That's how it's going to be, and then moving further we'll have an int M. That will always be a constant matrix, a 2-dimensional matrix, of course. And what that will be? That will be 1, 1, and that's each section, or this comma separated, indicating that it's in each row. for that matter, and that's what we are going to multiply. So how is that going to be? So we have to create another matrix, like say B, since any change in A would already be reflected, and that would create a mess in the multiplication. So I'll just create new int 2 by 2 matrix, and the product would be stored in, so like say B of 0 0 would be equal to M of 0. So let A be first. A of 0 0 times M of 0 0, the logic for multiplication, plus A of 0 1 times M of 1 0. That's going to be the first value, and we'll have B of 0 1 equal to A of 0 0 times M of, we could also write it with the help of for loops, but that would increase the complexity in this case because we have definite set of rows and columns, which is 2 by 2 here. But surely if you're quite interested in how the matrix multiplication is being done, I'll surely make a video in the future playlist, or I'll create a one that's like specific to matrix multiplication. And then we have 0 multiplied by 0 1, plus we have A of 0 1 being multiplied to M of 1 1. So I'll just copy paste this, and we have 1 0 equal to A of 1 0 multiplied by A of 0 0, and A of 1 1 being multiplied by M of 1 0. Like the second row would be multiplied by the first column, and then the second row for 1 1, it will be the second row, that's 1 0, being multiplied by the second column, that's equal to M times 0 1, the one that I've written above, and A of 1 1 being multiplied by M of 1 1. And now what all I got to do is equate the values to the A matrix, right? So A of 0 0 is B of 0 0, so that it would no longer create a chaos, and A of 0 1 equal to B of 0 1. Okay, I'll just copy paste this so that I don't waste much time in like writing it down. Okay, so it's 1 0 equal to 1 0 here. And this 1 1 being equated to 1 1. So that will be reflected in the matrix. So it's multiplied by A. So let's say if N is, like, print the 3 terms, right? So initially all we need to do is just print the initial terms, system.out.println, and what that would be, we will have for A of, we'll have, initially it will print A of 0, no sorry, initially it will print A of 1 1, that will be the initial term, plus space, okay, let's keep it print, plus A of 1 0 or 0 1, anything is fine. I'll just say 1 0 here, and then you'll have A of 0 0. that will be your final term. And after this we'll have system.out.print space with a of 0 0. And since it's already the third term, I'm initiating it like 0 1 2, and that starts from the third term. You'll multiply that, display the third term, and if it's like say the 5 terms, right, so it would be 3 and 4 more, 0 1 2 3 4. And let's say if this is only true if n should be greater than 2, so it should be 3, then only do this, right? So and this is what it's going to do. And we'll also have some else if condition saying that if n equals, let's say the 0, like the 1 term, 3 terms, right? So if n is 3, okay, so it should be greater than 3 for that matter, sorry, should be greater than 3. Else if it's like, let's go in the descending order, if let's say n equals 3, we'll only have these 3 terms. Else if n equals 2, we'll have the following 2 terms. And what those terms are gonna be, it's gonna be just 0 and 1, right? So it will have a of 1 1, and then it will have a of 1 0. Moving further, so we'll have another else if condition, like else if n equals 1. What that will be, if just it's the first term, you just want 1 term, right? That's 0, so only have this. Let's see if it works fine. And for else, we'll just say print please select a number equal a number greater than 0. So that's it, right? So if it's 4, right, so if it's 4, it will execute it for 3, so that would be 0 1 1 2, and the third value, that's gonna be 3. So let's compile it. We aren't getting any errors, so let's just skim through the program. Execute like void main. Let's say 0. Please select a number greater than 0. Execute it back again. We could also put this in a loop, not a problem. But for time being, so let's, if it's like say 1, then it's printing 0. Works fine for me. And let's take a number that's greater with, let's say 4, so it prints the 4 terms. Let's say 5 now, prints the 5th term, or like let's go ahead and say the 10 terms, prints the 10 terms. So that's it from this video. Thank you for watching. So if you haven't watched my previous videos, I'll be posting them in the description below. Thank you everyone. Please like, share and subscribe for more Brooked content. Thank you and have a nice day.